And then I had to write an email to Elon explaining why I deserved to join the autopilot team without a degree. Yeah, exactly. And he responded to my email and asked me like 3 questions. He's like, why do you think that, you're the right fit for this team? But I answered those and he responded, cool, just cool. And I didn't know what that meant. But like 3 days later, I got the offer letter.
Welcome to The Edge of Infinity, a podcast of builders talking to other builders in the AI space. Together, we discuss where the field is at today and make predictions about how things are going to look like in 5, 10, 100 years' time. I'm your host, Lina Colucci. Thanks for joining me as we imagine the future of AI together. Today, we talk with George Morgan, who is the founder and CEO of a moonshot AI company here in Silicon Valley. George believes that the way we train AI models today is fundamentally broken and will not get us to AGI. So the approach that he's taking at his company, Symbolica, is completely different. If it works, Symbolica's approach will change a lot about AI and the economics of AI. It'll enable us to have AI models that are orders of magnitude faster and cheaper than what exists today, plus with a lot more capabilities. George is also just a fascinating human being, and there's so many fun stories in this episode. For example, George had to email Elon Musk in order to get his job at Tesla. So we'll talk about that email, what Elon said, what George learned from years of working directly with Elon, his differences with Andrej Kaparthy while they were both at Tesla. George worked with Mr. Beast, who's the most famous YouTuber in the world, to recreate a Squid Games game on YouTube. And George built the hardware for that in his garage. George also had this long obsession with robots, and one robot in particular that took him on this 20-year-long saga around the world. We'll talk about all of that, plus our predictions for AGI, the future of AI, in this episode. And without further ado, I hope you enjoy my conversation with George. George, welcome to the show.
Thanks so much for having me. Yeah, it's great to be here.
So I was chatting with one of our mutual friends. He said that you're really into robots and that your search for a robot took you all the way to Japan one time. So I was wondering, what is this robot story that took you to Japan?
Yeah, that's a great question. This is probably one of the weirdest, strangest, and most ambitious things I've done. One of the projects that I've worked on over the longest period of time that eventually ended up coming to fruition in such a strange way. It starts all the way back when I was 7 years old. So my mom took me to Barnes and Noble. And, this is something that we would do together all the time, just as a pastime. My mom would always take me to Barnes & Noble and say, you can buy one book, whatever you want. As long as you promise to read it, you can buy the book. And so we went to Barnes & Noble, and that day I found a book on robots. And I was like, this looks really cool. This is something that I really want to learn more about. And of course, it's basically just a picture book when you're 7. But, I knew I wanted it. There was a picture of a robotic giraffe on the front of it, which I thought was really cool. And so I picked that book out, I came home and I read it. And on the 3rd page, there's a robot called Sony QRIO. And it's an entertainment robot built by Sony that never ended up being sold or produced. It was kind of like the companion to Sony's robot dog, the Aibo, the humanoid version of the Aibo robot.
Interesting.
And I instantaneously fell in love with this robot, and I wanted one. And
just from the picture in the book.
Absolutely. Oh yeah. It was I immediately became super obsessed with it. And I Googled everything I possibly could about it. And I was pretty sad to realize you couldn't actually buy them because, they weren't for sale. Now at the time I was learning about this robot, Sony was still actively doing research on it. Sony has an AI laboratory called the Sony Dynamics Research Laboratory. Sony Intelligence Dynamics Research Laboratory. It's since been rebranded to Sony AI, but that's kind of a separate little story to tell. But yeah, Sony was still very much working on this robot, and I kind of my goal in life, at the time, like my only goal in life was going to Japan and getting a chance to see this robot in person. And
At
I
age
begged my
7.
mom at age 7. Yeah. And so I begged my mom, I was like, please take me to Japan. Like, it's all I want to do. I even started learning Japanese. I mean,
Really?
learning, like yeah, like, like it was just like one of my little obsessions, like, that I had when I was 7. But yeah, the years passed and I ended up, doing other things. At some point along that process, Sony ended up canceling the project. So like news publications and information about the robot just completely ceased from like 2004 on. So I want to say like in probably like 2019, I was doing some more research on the robot. I saw, really nothing had been published about it since 2004. And I was kind of curious. I was like, I wonder if any of these robots actually still exist. And so I kind of like started pouring a lot of my time into trying to see if I could find anyone that knew anything about the robot. And like I sent out a bunch of emails to a bunch of different people, most of which I never got a response from, but eventually got a response from one of the people that actually worked on motion planning for the robot back at Sony at the lab. And he agreed to get lunch with me because he works in the Bay Area. And so we went and got lunch at a Japanese restaurant. He told me that all of the prototypes were crushed, just completely destroyed.
On purpose?
On purpose, yeah. Because in order to save Sony from bankruptcy, they basically had to eliminate any sort of like, R&D output done by the team. And so they had to like crush all these robots. And then they could do a big tax write-off. There's all sorts of these corporate politics, but it in part saved the company. But, he said, I do know one person who might know if one of them still exists. And so I got an introduction to that person, and that person said, I can't think of any that still exist, but I can keep my eyes peeled. A couple years later, I get an email from him saying I found one. And
No way.
I was elated. Like I could not believe it. And this was like during the height of COVID. So it was impossible to get into Japan. Like literally tourists were not allowed. You could not get into the country. The only way to get into the country was to get a business visa for business purposes. And so I pulled some strings, and I ended up having some friends of mine that were going to Japan for business purposes as well. And I kind of like hopped on the train of their business visa. And I ended up by like some crazy miracle getting into the country. And then we went to the Sony building and, pulled this thing out of storage and turned it on for the first time in 20 plus years.
Oh my gosh.
And it turned on. Yeah, it was amazing. It was one of the coolest things I've ever done.
That's incredible. Most people don't have their Moby Dick like saga start so early, but you had one, right? This like 20 plus year saga. And what happened? Did you get to keep it?
No, I didn't get to keep it.
But you got to turn it on.
Really cool. Yeah, got to turn it on. We got to go through all of like its diagnostics menus, and like, there's so much stuff that I learned about the robot that's just not documented anywhere at all, because like all of the videos taken of it before the project was shut down are all on like digital cameras from like 2004. So it's all like potato quality video and like super compressed audio. And there's really not that much high fidelity video of the robot on the internet. And so like there's so many details of how it moves and how like you interact with it that just aren't present on the internet. And so like I got to see all of these details, and we got to go through all of its like diagnostics menus, and like everything was in Japanese too. So the person that I was with spoke Japanese and English, and he was like translating to me what the menus were saying.
So cool. Did you get any photos with it, or was it top secret behind, can't tell the world this exists?
Yeah, so I got very high resolution photos and video of it. Sony was like just like incredibly supportive of me coming in and taking pictures of it. We got permission from Sony to do that, and not only that, But the day that I was there, the person who was with me, kind of like pulling this thing out of storage and turning it on, sent a message on the internal like Sony Teams chat to the creator of the robot, the person that started the project, and said, "Hey, there's this kid here that like really wanted to see this, QRIO robot. Are you in the office today?" And by some miracle, this was like the one day that month that he was in the office. And he came by and introduced himself to me, and I got a photo with him, the creator of the robot.
Oh my gosh, that's amazing. Well, if you have that photo, we can add it to the show notes of the podcast after. And also, I need to go look up this robot now, and we'll definitely include it in the show notes as well.
Sounds great. Yeah, I can give it to you.
That's the coolest story ever. So George, you're the founder of Symbolica, and the way I describe your company to other folks is the most important company being built in Silicon Valley right now. It's a moonshot, right? What you guys are going after. But if things work the way you hope that they'll work, right, it's going to be a game changer for the way AI is done in the world. And so your mission is make machines like humans, think symbolically, not statistically. So what does that mean, and what are you guys doing at Symbolica?
Yeah, you're absolutely right. Symbolica is kind of a total moonshot idea in AI. And I think you did a really concise job at kind of explaining what our mission is. For some context, all current machine learning algorithms, can effectively be thought of as a form of computational statistics. So basically, we all kind of took statistics classes in high school and learned about probability distributions and like all sorts of these kinds of phenomena that happen in observed data. And machine learning is like an extremely beefy, scaled up version of what are pretty, simple statistical methods. And they're scaled up into high dimensions, and they're trained using lots and lots of data. But ultimately, name of the game in machine learning is figure out how to most accurately continue the pattern, statistically speaking. So for large language models, for instance, they've been trained on a massive corpora of text from the internet, and they've learned the statistics of language. So like, what's the likelihood that these words will appear around these words? What's the likelihood that this word will follow that word? Through a process called co-occurrence. Like, there's so many phenomenon that, these language models are picking up on and learning. But fundamentally, what it all boils down to is just picking the right next word, the next predicted token, essentially. And the model basically, inside of all of its weights and, all of its complex, internal machinery, is just kind of computing like, oh, given all of the previous words, tokens, what's the most likely next word to come?
So if it's like, my name, the most likely next word is going to be is, right? My name is.
Exactly.
Is going to be a high likelihood token. And then just extending that to, given 1,000 previous tokens, what's the next most likely one?
Precisely. And this analogy extends across any form of AI model today. We have these image generation models, like diffusion, for instance, like Stable Diffusion and DALL-E and all of these kinds of diffusion-based models. The way that these work is they start with completely random noise. And then at each step, the model is asked to predict what the most likely way to unscramble the noise is to get to something that matches what prompt is provided. So it's learned a whole bunch of correlations between prompts and ways to like unscramble the noise in order to kind of get closer and closer to something that statistically matches and is correlated with the prompts that it was trained on. And, all sorts of image classification algorithms kind of use the same process. Like every machine learning architecture that's widely deployed today is based on statistics, computational statistics. And, this works extremely well, but in my opinion, it's lacking in a lot of the things that are required to get to true cognition and build a true cognitive model. And there have been lots of proposals about how to extend these machine learning architectures with various kinds of cognitive models like JEPA, Voyager, all these other kinds of interesting techniques that are coming out to actually kind of supplement these statistical embeddings with other cognitive tools that could be used to kind of start to achieve logic, reasoning, localization in spaces, and stuff like that. But so far, not to make a sweeping generalization, most of these techniques have not worked, or at least they haven't really worked in a way that's like had as big of an impact as something like GPT has with its statistical prediction. And so Symbolica, the moonshot company, is to figure out a way to build a machine learning architecture that's not based on statistics, but is instead based upon the manipulation of symbols directly, that eventually yields things like online learning, causal reasoning, the ability to understand like ontology of information and so on, that ultimately leads to general intelligence by some definition of that far down the road. We have intermediary business goals, but like the like overarching North Star goal of the company is to build general intelligence.
Fascinating. And I have so many questions about different things you said, but just to try to provide a mental model here, what does it mean to represent things in symbols instead of statistics and floating point values? What does it mean to kind of represent things symbolically?
Yeah. So, I mean, perhaps the most like simple symbolic system that everyone's familiar with is algebra, right? Like, there's super simple algebra like addition, right? Like everyone knows the rules of like 1 + 1 = 2. You can kind of have variable substitution, which is like x + y = something. And then you can start to chain multiple of these expressions together to form systems of equations. And like you can, use the relationships between these variables and these equations to like, figure out what other variables in the equations mean and so on and so forth. And this, I think, is like basically kind of at its core, all symbolic is. It's, building up relationships between things that may not have explicit names, so they're symbols. And via those relationships between those things, you can, express information and encode information in some way. Really, all it means to be symbolic is to be able to write down the explicit relationships between entities, datums, quanta, some individual, base thing, and other versions of those individual base units to build a symbolic system.
Mm-hmm. Am I thinking about this correctly? Let's say, I'm asking a model, what is 2 + 2, rather than kind of saying, oh, it is approximately 4. It's no, I know that when you have x + y, this is how I compute the relationship this is how I compute the result. And so that's a very, trite example, but is that the right mental model of thinking about it?
Exactly, right? Like somehow the human brain, via whatever process it learns through, has learned to build a mental model of symbols. So like individual numbers, 1, 2, 3, so on. And you can kind of generalize up to infinity what those numbers would be. Like we have patterns in our brain for like, adding another digit, carrying a digit, how to like do the addition operation between all these things. That's all rule based, right? And our brain has kind of learned those rules for manipulating these symbols. When we, are asked like, what's 1 + 2? Your brain doesn't just execute a neural function that then spits out the answer 2 as some probability distribution. Your brain actually goes through and it steps through the procedure, symbol plus that operation is a rule. I take this operand, I combine them through this rule. And you do that over and over again until you get to the end result, which is your evaluated function or whatever it is. Maybe for super simple functions like 1 + 1, we've all memorized the answer. Like we've just
it's cached.
We've memoized it, which is to say that we've evaluated it once and then just stored the result of that computation, and now we can use it. But if I asked you like, what's some arbitrary 5-digit number plus some arbitrary 5-digit number, you'd have to like sit there and like kind of draw it in your head and actually go through the steps of evaluating it. It's not just like a one-shot sort of like, I collapse this probability distribution down to an answer, which is what a neural network would do if you, for example, trained it to add 2 numbers together.
Makes sense. And how should I think about Symbolica's approach? So let's say, you guys are going to create a version of ChatGPT, right? Of large language models that can generate text. What would that process look like? Do you still need a massive data set to begin? Are you learning the relationships there through some kind of supervised approach? We kind of understand machine learning today, in the supervised sense of you have your data and your labels and you're learning the relationships there. What does it look like in the Symbolica model of the world?
Yeah, that's a great question. So I think that exact question almost exactly defines what makes Symbolica different. So when you're training a machine learning model, like let's just take like the transformer, right? Like the T in GPT, right? Like all of these language models are based on this transformer architecture. And, like we mentioned before, like the goal of the transformer is to, given some input sequence of tokens, predict the next token in that sequence. So when OpenAI is actually training these large GPT models, they're basically like taking their entire data set, masking off all the ending tokens, saying, okay, here's just one token, predict the next token. The model will probably get it wrong. Then they show the model the actual next token in the data set. So this is a form of self-supervised learning. And then they correct it. And then they do this over a corpus of potentially trillions of tokens. They may train it the same sequence of tokens in multiple times, right? What's actually happening is inside the model, you have a function, that takes some sequence and then it produces some token. And so there's some explicit notion of input and output, and there's some explicit notion of being correct or incorrect. You either predicted the right next token or you did not predict the right next token. And as such, you brought up this notion of like data and labels. You can think of like the data set as being both the data and labels at the same time, depending on how you mask out the next token and so on.
Totally.
This is actually one of the kind of like fundamental architectural issues that I see with neural networks, is that it's really, really hard to specify a network architecture that's not in the form of like f of x equals y, a function, input layer to output layer. Like that is kind of the definition of a neural network. You're trying to build a universal function to, where you're using the framework of universal function approximator to learn some map from some input space to some output space, from some data to some label. And the transformer is certainly no exception to this. So in the Symbolica architecture, kind of following by analogy, there is no notion of data and labels. You only have a notion of data. And the intuition behind this is that the data set that trains these large transformer models is, it contains all of the labels already. It contains all of the information that you would use to correct the function. And so, why would you need to explicitly provide the model with like the labels if they're kind of already present in the data? And the reframing that I think has been really powerful for us building Symbolica is that the data, and at least in the case of language, is the labels. And moreover, the data is actually the model itself. So if you can think of like using your data set as the model, like the data set is the function, or it is the definition of the rules. And instead you almost like flip the problem on its head. And instead of like forcing some predefined neural network architecture, like the transformer, to like form itself to the problem of the data set, can you think of it the other way and say like forming some algorithm over the data to form the algorithm to the immutable data? And that's really kind of how we've approached the problem. So all of the Symbolica models, use data as instructions that update the model being basically a way of interpreting the data, rather than using the data to update some weights in a network.
Fascinating. Is it correct to think about, today we have the traditional model of training in a supervised way. There's data and labels, and a result of that training process is getting an embedding space, right? That is, less human interpretable, but still very semantically meaningful of the distribution of data. Is what you're saying that today with, let's say, the transformer architecture, we kind of fit all data into a specific kind of embedding space. And with Symbolica, you don't take a predefined approach and you just let the data tell you what it's embedding or what its kind of, highly dimensional distribution should be.
That's exactly right. That's like a really beautiful way to look at it. In fact, there's a hypothesis that precisely describes what you just said. It's called the manifold hypothesis. And basically what the manifold hypothesis states is that all of the data that we find in the natural world, whether it's like images or text or audio or whatever, it's embedded on a manifold. Well, what is a manifold? It's really just a fancy mathematical word for some surface that you could walk over if you were an ant. So like, imagine you're like an ant on a donut. A donut would be a manifold, but no matter where you are on the surface of that manifold or donut as an ant, you could always walk in a straight line around that surface, and you could just keep walking and keep walking and keep walking. And so the same thing is true of all of the data that exists in the natural world. It's just on the surface of some incomprehensibly complicated high-dimensional shape of some sort that's got all these kinds of like local properties and so on. And basically what you're saying is like, well, we can't control the shape of that manifold. Like it's just out there. It's just like it's kind of like the laws of physics. It's just like a fact of life. Like the data of natural language is just on this surface somewhere. And what you're trying to do when you're trying to train a neural network is you're trying to take samples on that manifold that exists in the ether somewhere, and you're trying to like force a low fidelity representation of some synthetic manifold you're building to conform to the shape of that natural manifold. And you're doing that by turning all these little knobs in the neural network. Each little knob, turning it a little bit, corresponds to changing the shape of that surface just very slightly. And you're trying to like turn all those knobs such that that surface kind of warps a little bit like Play-Doh, like over the natural manifold of things. And really the thesis of Symbolica is like, why spend all that extra computation to like force all these little knobs to be turned into, something that kind of vacuum forms over the natural manifold? Why not just use the data, which in itself is like kind of a sample of that natural manifold, to define the outline of it? Basically use, a simple set of procedures to kind of like, wrap, a little string around these little data points you already have in your data set, and then you have a wireframe kind of representation of this manifold.
Very cool. And so how many manifolds will there be? Is there a language, like a generative language one, or does all language kind of fit in one? So what I mean by that is ChatGPT is, synthesizes language, but it can also be used as a class of all sorts of NLP classification tasks, sentiment classification, named entity recognition, basically any NLP task it can do. In the Symbolica model of the world, do we have a language manifold and then a separate, natural images manifold? Is it multimodal? Like, how do you see it playing out?
That's a great question. So I've only been thinking about text so far. So anything beyond this would just kind of be a speculation about what I think will happen. But I'm happy to speculate about it.
Well, we can focus on the language. Is it one manifold for language in the same way, we have a massive embedding space in GPT-4 for language, or is it somehow different in this new paradigm?
Right. So for just language, it's only one. So, you kind of probably have heard this term like latent space, right? There exists some latent space that the model's operating within. And in a neural network, typically you have many, many latent spaces. In fact, the process of dimensionality reduction is basically kind of projecting one latent space into another. Each successive latent space gets a little tinier until you just end up with one really tiny, super easy to understand latent space like R2 or R3 or something like that. In the Symbolica model, you only have one latent space. And you're basically just performing operations, over the fabric of that one latent space over and over and over and over. Never sort of like reducing dimensionality like you might expect in a neural network.
Got it. And so one of the benefits that you mentioned of this approach is online learning. What is online learning, and what do you mean by that?
I think it's probably easiest to kind of contrast against like neural networks. So neural networks are basically, like I mentioned, just a function, that maps some input to some output. The way that machine learning currently works is that you have to train that function. Like it starts out being completely incorrect and inaccurate. And over time, by turning these little knobs to kind of approximate this like manifold that we were talking about, this high dimensional surface, high dimensional shape, that function slowly gets a little bit more and more and more accurate. However, due to the algorithm that's used to train these models, gradient descent, once you've stopped descending through the gradient, like once you've stopped like optimizing to find the global or local minima, you're done. Like, that function is fixed. It doesn't change anymore. The input you provide to the function doesn't change the function. It's still just like the same function. And there are these things, like transformers, which are called autoregressive models, which is that you like take kind of part of the output of the function and you feed that output back into the input of the function. But, of course, like you can always just collapse that down and represent that as a static function as well. The process of online learning is basically almost as if you continue running gradient descent or whatever the analog of that is in whatever model we're talking about here. And you're not only always updating the function, but you're updating the process that updates the function. So this is like what the brain is doing. Like the brain is receiving information, and that information is producing an output, like it's producing an action reaction in you, but it's also updating the function that you use to then interpret data in the future. So it's causing you to change the way you perceive future data. So your inputs actually impact the way that you perceive future inputs. And that's kind of how I would define online learning.
So it's the ability to kind of update your internal correlations and predictions in real time in response to information instead of having to go through an entire new long training process.
Exactly. Like it enables you to interpret the next set of inputs differently based on your previous set of inputs that you got. Without having to take a detour through some kind of like offline optimization process. In a neural network, it's theoretically possible to do this. Like you could always like feed some input into the neural network, run gradient descent, then feed the next thing into a neural network, run gradient descent. But due to sort of compute limitations, this isn't feasible. And also due to the kind of limitations of the way the problem is structured, like some input to output pair, if you don't have the label, if you don't have the output, if you don't know how to, tell the model how it was wrong, then you can't do that. So for instance, like classification models, you might not always have the labels available to you online. So this isn't really something that can be done with neural networks very effectively.
Yeah. And it's interesting because we've talked about Voyager in the past, and the thing that I think is so cool there, and my mental shift over the past few months, probably marking around that Voyager paper coming out, is really thinking of LLMs, but let's just call, these new class of models as reasoning engines rather than models that need to have specific knowledge encoded in them. And once I shifted my mental model of that, it seems so archaic to require a long training process, back propagation to just update a model with information. The Voyager approach to things is you have this reasoning unit and you can point it to stores of information, to knowledge stores, and have it reason about it and then write down its conclusions and build up from there, which is, what I do as a human. I don't have everything in my brain. I go look at a textbook or I look at Wikipedia, reason about that information, and then draw conclusions. And what you're saying is the Symbolica approach is similar to that. It's archaic to think of models as needing to, at the extreme, like be trained every hour because there's more information generated in the world every hour of the day. That doesn't make sense, right? A, that's not feasible. B, it's, there are alternatives. And what you guys are building is an alternative way to do this online learning and to update models.
Precisely. Yeah. That is a great definition of exactly what we're trying to do.
And so if we project out, however many years you guys have achieved your vision, what will we be able to do? What does the world look like? Because Symbolica has achieved this new paradigm of training models?
Yeah, so we're really aiming to achieve two things. If we achieve either one of them, I would consider it to be successful. In an ideal world, we achieve both of them. The first thing is the thing we just discussed. It's like this notion of like online learning, the ability to do causal reasoning. So, eventually be able to understand how to compose the rules of addition, for instance, at a high level without being explicitly instructed or trained on exactly what these rules are a priori. That's kind of like the first goal. The second goal is making this whole process much more compute efficient to achieve. So one thing that I think doesn't get talked about enough is just how computationally expensive it is to train these large machine learning models. It cost OpenAI a reported $400 million just in compute to train GPT-4, which is, completely out of the question for any, startup or even small scale company to be able to attempt to do. The only reason OpenAI can afford to do this is because they're backed by an insane amount of VC funding and Microsoft. And, there's a lot of computer architectural reasons why it's super expensive. But, it kind of ultimately boils down to the fact that doing floating point operations, especially like high precision floating point operations, is basically the most expensive operation you can do on a computer. And the only hardware we have right now that's really good at doing general purpose floating point operations are GPUs. And GPUs are extremely expensive. And then also, like in general, the operations you're performing are like costly in terms of how much time it takes to perform a single operation. I don't know the numbers right off the top of my head, but it takes somewhere on the order of like 100 or like 200 times longer to do a floating point operation than an integer operation, somewhere kind of in that ballpark. And all of these machine learning models are based on these operations. And so, part of Symbolica's goal is to figure out how to do everything using just integer operations. If we can accomplish that, we'd be able to train machine learning models on GPUs still quickly, but we'd also be able to train them on CPUs. And CPUs are drastically cheaper and more energy efficient than GPUs. Those are kind of the two goals of the business: is make training these models and doing inference on them drastically cheaper. Even if it's like no better than existing machine learning models today, that would still be a big deal. And then on the other hand, using pure symbolics, we believe we can unlock these expanded capabilities. And even if we were able to accomplish that, but it wasn't necessarily cheaper, it'd still be a big deal. But we really want to accomplish these two things together.
Fascinating. What will be, in your mind, the first milestone of showing the world what you guys can do? Like, what would be your ChatGPT moment?
Yeah, so we're currently working on this thing called SymChat. And SymChat is basically just the Symbolica version of GPT. And it's, basically designed to be interacted with the same as GPT, with, one limitation removed, which is that there's no context window anymore. So there's not a fixed number of tokens you can feed into the model. And the limitation removed that you would have to fine tune the model in order to get the model to attend more, for instance, to specific kinds of information. So the goal is that you would be able to communicate with your sim agent and basically just instruct it using natural language and teach it basically using as many tokens as you need to actually teach the model how to do specific tasks. Through the interaction of these two components, online learning and no context window limitation, basically fine tune your model to whatever task you want to fine tune it to, just using natural language. And I think if we can get to that, that would be like an absolutely amazing ChatGPT moment.
I mean, I think you had most people at, GPT without a context window limitation. As much as I want to keep going on this, I want to switch gears a little bit and talk. So prior to starting Symbolica, you were at Tesla for many years. And so I'm curious, how was that? And what did you learn about running a company from Elon Musk?
Yeah, I mean, Tesla was an incredibly formative part of my career. I'm extremely, extremely lucky that I had a chance to join Tesla when I did and join the team that I did. So, for context, I ended up dropping out of college after 2 years. And I bought a one-way plane ticket from Rochester, New York, where I went to college, to San Francisco. I had no idea what I was going to do. And, I didn't have very much money in my savings account. And it was like a fairly risky decision that I can't say made my parents too happy. But I was basically determined to make it work by whatever means that I could. And, skipping a couple details, I eventually ended up getting an internship at Tesla. When I was like kind of arguing with the recruiter about like what internship position I'd be holding, I kept saying, I want to build robots. I want to do robotics. I want to work on the autopilot team. And the recruiter was basically like, oh, we don't have any positions on the autopilot team. And I was like, please, please, is there any way we could make an internship position? Or like, I just I really, really want to work on that team. Cause I mean, I don't, like, it's not that I don't care about cars, but I just didn't have any interest in cars. I had interest in robots, and autopilot is just turns the car into a robot. So I was very interested in that. So I was begging the recruiter to please let me do an internship on the autopilot team, and Gigi, and absolutely like the best recruiter of all time, ended up pulling some strings and got me an internship on the autopilot team. And so I got to kind of get in at what was arguably the ground floor of autopilot. Like Andrej Kaparthy had just joined, like the system was barely based on neural nets, doing kind of this computer vision stuff. It was like fresh, off hardware one. Hardware two was kind of had just been widely deployed. And man, it was like getting thrown into the deep end as an intern. Like it was like, hey, here you are, cool. You have all the responsibility and more of a full-time employee. Here's these 20 projects. Please get them all done. It was like absolutely this crazy experience that I had no expectation of what it would be like. Like I'd had a couple people tell me that working for Tesla was hard, but I was like, it's probably fine. But no, I got there and it was like instantaneously I got thrown into the deep end. And after about 3 months of working there, I was like, this is what I want to do. Like, this is so much fun. I'm really good at this. And so basically I went back to my same recruiter and I was like, can I please just join full time, even though I don't have a degree? And she was like, I really don't think that's possible. Like, we don't really do that. Like, especially for the autopilot team, like that's like a really, like the team is like really, really exclusive. Like, I don't know if we're going to be able to swing this. And I don't really know exactly how it ended up happening. Like I said, Gigi, if you're watching this, best recruiter ever, she ended up somehow getting an exception from the director. And then I had to write an email to Elon explaining why I deserved to join the autopilot team without a degree. Yeah, exactly. And he responded to my email and asked me like 3 questions. He's like, why do you think that, you're the right fit for this team? And some other questions I kind of forget off the top of my head, but I answered those and he responded, cool, just cool. And I didn't know what that meant, but like 3 days later, I got the offer letter.
I guess it went well.
That's right. And so, yeah, after doing a 3-month internship, I got the full-time job at Tesla. And then after that, it was just a wild adventure. I mean, way too much to go into in the podcast, but, weekly meetings with Elon, like staying till 3 a.m., going out on drives to fix bugs on like 4 hours of sleep, like just absolutely crazy. Launching FSD at the AI day, the first autonomy day. Oh man, that was just a life experience. Like, it was amazing. Like the team is absolutely incredible. Working with Elon is very stressful, but like, an incredible learning opportunity.
Is it stressful because he just demands a lot of you, or he's just a, extreme personality? Like what's difficult about working with Elon?
Failure is not an option. In all of my interactions with him, he was always like very like understanding and calm, and like there was never any like aspect of like being upset or short or anything like that. But I did, there were certainly cases where like when people weren't getting their job done or saying that's not possible, or like taking too long to solve the problem, that's when like the wrath came out. Like he was very much relentless in terms of like being able to solve the problem. And yeah, like saying it's not possible is just not a solution. So like you were always under pressure to figure out some way to get it done. And that was a very formative sort of like educational process by which like, if I didn't have a solution to the problem, I had to completely rewire how I was thinking about the problem to come up with a solution. And that's been dramatically valuable to me in starting the company.
Mm-hmm. Fascinating. Yeah, some of my friends, I have different friends that work across his companies. I think one of my friends at Neuralink has said something very similar about, they're doing everything from the ground up there, from, the material science, clean room, microfab, all of that. And just the amount that Elon pushes them to just, there was one point where they had a pretty, formed chip, and then it was just start from scratch, right? It was like, this is not working. We've hit a wall. Like, let's just start from scratch. And that actually enabled them to find a path toward that, would have not been possible with the previous approach. And I've just heard again and again people saying, he pushes you to do the best work of your, get the best out of you.
Yeah, the sunk cost fallacy is not a thing in his mind.
Not a thing, right?
Yeah,
which is it's such a normal human way of thinking. And he somehow doesn't have that at all. Were you ever in the room where he was, unleashing his wrath on people?
Oh yeah. Yeah, he called me once, like just out of the blue, on my cell phone, and I didn't recognize the number. And was very, very passionate about a problem we were having and demanding solutions for it.
Fascinating.
And there were lots of meetings where we're all working together trying to solve a problem, and things would get very intense. Like it was part of the culture, but that's how things got done. Without that, there really wouldn't have been the impetus to invent drastically new technology.
I mean, that is really inspiring to hear. And, this podcast is inspired by one of my favorite books. It's called The Beginning of Infinity. I actually have it behind me there. And one of the phrases from the book is problems are soluble. And then the other thing that book changed the way I think about things is everything that doesn't break the laws of physics is possible. If you project out to infinity, everything that doesn't break the laws of physics will exist, because infinity is a very long time. And so what that means is project out to infinity. Let's figure out how things are going to be done there, right? And then backtrack to today and figure out how can I start building towards that future. So it's inspiring to hear, the failure is not an option. And it's really this thinking that taken to the extreme of problems are soluble. And as long as we're not trying to break the laws of physics, we can figure this out, and there will be a path forward here.
I couldn't agree more. And Elon takes that thought process to the extreme.
And then you mentioned Andrej had just joined the team. What was that like working with him, and what did you learn from Andrej?
It's a good question. Well, I'll preface this by saying Andrej and I don't really get along. Okay. And I think that, most of that is ideological. Of course, in starting Symbolica, I'm basically making the statement that I don't believe in the future of deep learning. That is basically all his life, Andrej's philosophy. is that deep learning is all you need. Deep learning will scale to infinity and solve all problems. He calls this software 2.0. And this is exactly what he brought to Tesla. Idea was that we would train bigger and bigger and bigger neural networks to solve the self-driving problem. And, that ultimately ended up not really panning out. Tesla still hasn't solved the self-driving problem, not due to lack of talent or, lack of ambition, but in my opinion, due to the failings of deep learning. Of course, Andrej ended up leaving Tesla to go back to OpenAI. I'm not sure about the specific reasons of that, but I think that the process of, making the promise so many times of scaling the neural networks will solve the problem, and then having that not be the case, is really draining. And, when that's your core philosophy, and that's the promise you keep making and it keeps not happening, I can imagine that kind of taking a little bit of a psychological toll. Andrej's clearly a very smart guy, did an insane amount for Tesla, built the vision team, built the labeling team, really turned autopilot into what it was today. But, he and I disagree to a point of great personal contention ideologically about the future of AI. So I'll leave it at that.
Yeah, makes sense. And thank you for sharing that too. One of the things I always think is interesting to ask founders is, in Symbolica is the second company you've started. How would you describe the difference between being a founder and an employee?
I think a lot of this kind of comes from what I learned from Elon working at Tesla. One of the things that Elon always said to us, usually at the end of all of our really intense meetings, he'd say look, guys, I know that this is an extremely hard problem. And I want you to know that you can call me anytime. Here's my cell, call me, email me, set up a meeting. I don't care if it's at 4 a.m. Just call me, we're going to solve the problem. And I always thought that was so interesting. I was like the world's richest person, probably the world's busiest person is saying, call him at 4 a.m. When I first heard this, it didn't compute in my brain. I was this is so strange. I didn't really understand what he was saying. But then, over the years, eventually it kind of clicked. And, Elon kind of himself in interviews has described this as being the inverted pyramid. It's his role is to be at the bottom of that pyramid and support the weight of everyone on top of him. And, as an employee of Elon, you're really not actually working for Elon. He views it as he's working for you. So whatever you need to succeed as an employee to solve the problems, you ask Elon for at the bottom of the structure to, gain access to resources or compute or the person or whatever it is that you need to solve the problem. And he's always there to act as the intermediary between you and whatever you need to get to solve the problem. And as soon as I kind of really realized that's his philosophy and that's, how he operates and how he runs his companies, it immediately became clear to me that is why all of these companies are so successful. You're not sitting in a castle in the clouds as a CEO, you lording over all the peasants or something like that. It's actually quite the opposite. You're at the bottom. You're sleeping on the factory floor. You're doing everything you possibly can to make sure your employees are successful. And I very much carry that over to the new company. It's the only person driving this to success is you. If you're not there every moment of the day thinking about the project and figuring out how to support your employees and figuring out how to get them access to the resources they need to solve the problem, you're not going to succeed. And so that's really kind of what I view the difference between being a founder or a leader and an employee is as a founder, the job is much harder. It requires much more involvement and thinking. And I hope to emulate that being a founder at Symbolica.
Yeah. And it sounds like it's also a shift on the employee mindset that Elon kind of encourages too, of a shift to extreme ownership. Yep. Of it's on Elon to support the employees and make sure they're empowered to do their jobs and achieve the company's mission. And it's on the employees to be actively thinking through what is standing in the way of me achieving my role in this company's mission, right?
That's right.
And it's interesting that the framing you put it is actually goes in both ways. It's both sides take extreme ownership, and it actually is very empowering for a team member, right? To be like, this is my role, this is my mission, and I should be proactive in figuring out what I need to be unblocked to achieve this mission.
That's crucial. Like, Tesla hired the best teams because every employee had that attitude. It's like, what do I do to solve this problem? And how do I get access to the resources I need to solve it?
So thinking a little bit about AGI, you mentioned your mission at Symbolica is to create AGI, pave the way for AGI. My question is, what is your definition of AGI, and how will we know when we've achieved it?
AGI is one of those terms where it's very hand wavy. It's not defined. It's kind of a abstraction. But if I really, really had to kind of point at what I would say, or like if I saw a system and I point at it and said, that's AGI, I think that it would be a system that's capable of learning how to solve any task a human is capable of solving, given the same input that a human would receive to learn how to solve that task. So basically, just by being instructed, the same way you might sit down with someone and show them how to do algebra, or sit down with somebody and teach them, how to play the piano, or like any task, right? General. If you could show a machine how to do it the same way you should a human how to do it, and with no information beyond that, it was able to do that same task, I think that would be AGI.
Interesting. And where do you think we're missing today? Because I would argue in many realms, I would say GPT-4 has achieved that. I can give it less instruction than I would to a human and have it perform as desired. But there are certainly, plenty of places where it makes stupid mistakes and, has comical failures. So where do you think the biggest gaps are in that definition?
Yeah. So before I answer that question, I just kind of want to point out one thing. GPT is absolutely phenomenal at tricking you into thinking it's human. It's basically the best example of anthropomorphization we've ever seen in a machine, or really maybe ever. It's like the machine is a perfect facsimile of what it's like to behave like a human. But really all it is a facsimile of the outer presentation of what it's like to behave like a human. It doesn't have a model of what it is actually occurring inside the human mind. And it's actually extremely easy to prompt GPT with various kinds of questions that make it obvious that it doesn't have a consistent internal world model. And, the fact that it doesn't think and reason like humans. For instance, there's a very interesting paper that came out a couple weeks ago that described the fact that GPT can tell you clearly that there's some relation from A to B. But then if you open a new chat window and you say, what's the relation from B to A, it won't have any idea. And this is not something that humans have a problem with. And
I think the example I saw, just to make it clear, was, who is so-and-so's mom, for example. Let's say, who's Elon's mom, right? And it could answer that. But then if you're like, hey, who is, I forget his mom's name, but who is so-and-so, it would have no idea.
That's right. That's a good example. And so this is at least indicative that the behavior of GPT is kind of purely just a facade, an act. It's an approximation of what the outward facing behavior of a human is. So to kind of get back to answering your question, in order to build a system that, will kind of approach AGI and, kind of get rid of some of these limitations of GPT, inside of the model itself, it has to be capable of doing these kinds of reasoning and logic based operations that currently these models are not capable of doing. For instance, GPT can, generate pretty reasonably effective code if that code is in the space of things it's seen in its training set. Or you could give it code it hasn't seen in its training set and ask it to refactor it. And as long as that code is just a couple lines long, it can, infer the statistics of how to reorganize things to make it work. But if you ask GPT, code up a new algorithm that does X, Y, and Z, for the most part, it completely fails at this. And the reason why is that fundamentally statistics will not get you there. You cannot extrapolate, statistics and computation are not the same thing. You can't extrapolate just purely from the statistics of language how to do problem solving and reasoning. And given that GPT is purely an engine that's extrapolating from statistics, it's fundamentally incapable of performing the actual logic, reasoning, and computation required to say, code a new algorithm or solve a novel problem in quantum mechanics, or even something, much simpler build a CAD model that does this thing. And I think that, GPT is certainly an incredibly impressive feat of technology, but, it's not going to get us to AGI.
It's interesting. So I agree. I don't think GPT-4 is AGI, but I think I have a different point of view of, I don't fully know what is AGI. I mean, I think AGI is a lot of things thrown in there with intelligence plus consciousness, which I think is a very different vector. I don't know what consciousness is. Maybe that is just going to be an emergent property. There's, the ability for self-directed goals. There's the ability for kind of cognitive flexibility. So there's a lot involved in AGI. But I actually think GPT-4 is very good at reasoning. And it sounds like one of your definitions is, you gave the example of coding up a new algorithm. So you're thinking about intelligence as the ability to generate new knowledge, which I agree. I actually think that is the definition of intelligence. Again, I don't know what AGI is, but pure intelligence, I think it's the ability to generate new knowledge. And even when we look at, did you see that OpenAI paper where GPT-4 was explaining the neurons of GPT-2?
I saw that. Yeah.
So, it's an interesting example of having GPT-4 generate new knowledge that humans could have painstakingly done something similar, but would have taken forever. And so we had GPT-4 do it, and it does a fine job. It's not perfect, but it does a fine job. And it generated this new knowledge that the world did not know of before. And so I actually think sometimes people, use, these transformers are, pure autoregressive models and there's no way they can get to AGI. And again, I don't know about AGI, but I think for intelligence and reasoning capabilities, I think these are pretty damn impressive. And, if we scale up to GPT-5 and 6, I think it'll be able to do most things that humans can do on average today. It's not going to be perfect. And I think you bring up some great points on what types of things are missing from it. But yeah, I think I have a different take on kind of the current reasoning abilities of it.
So I think, I understand what you're arguing. And this is certainly there are very strong arguments in the opposite direction. And I don't know if I'm necessarily convinced, but that's okay. Only time will tell to see what actually ends up happening, whether these systems will scale into fully reasoning agents. I think nobody would have predicted that next token prediction would have gotten us to where we are today, for instance. In fact, if you'd asked me back in 2018, do I think that just predicting the next token will yield what we got? I would have said no. So I would have been wrong. However, one kind of subtle, piece of information I could supply that I'd just be interested in hearing what you think about how I think about this is having the source code, having like the files and folders of a repo is nowhere near the same as having the Git history of that repo. So there's a bunch of meta information that goes into synthesizing some artifact. So, like, for instance, the Git history could kind of be thought of a little bit as like the reasoning chain that got you from a blank piece of, like a blank editor with a blinking cursor to a novel algorithm. And there's kinds of these like intermediary steps, refactors, like moving things around and like, processes of modifying this information that, are, at least in some way an encoding of the human thought process, the human reasoning process by which we go from a blank canvas to a piece of artwork in the logical domain. Turns out it's a little bit easier, actually, and I think diffusion models have already kind of nailed it to go from a blank canvas to a piece of artwork, because that's inherently a statistical operation. But for code, where it's not a statistical operation, something like the Git history is actually a very necessary component of like displaying how that reasoning chain happened. Git history happens to be a very unique thing we can point at and say, oh, this actually is data that encodes the reasoning chain. Like these deltas, these diffs between each commit kind of encodes the reasoning chain coming out of the human brain. But for all other information that trains a GPT model, that doesn't exist. Like, for the most part, all of that is just in our heads. We don't even have a way to communicate this with other people. Like the reasoning chain and sort of the collapse of all of these like things in our brains is completely silent in our head only, and probably encoded in a way that's only compatible with our own internal mental models. And so, given that the human brain is clearly the only example we have of a system that's capable of forming these reasoning chains and collapsing them and so on, I think that if we wanted to have a machine learning model learn statistically to approximate or figure out the pattern of how that's happening, we would need that part of the training data. And none of the training data we have now has that information at all. So
100%.
I think that maybe transformers and deep learning models could potentially do that. However, we don't have access to data to get them to do that. So the only way to get them to do that with the data we have and the way that we've sampled and pulled the data out of the natural world is to construct a model that's capable of learning via this bootstrapping process, this process of building relationships, ontologies, hierarchies at different zoom levels. And statistics just simply can't do that. So that's my rebuttal.
Yeah, no, this is so interesting. Yeah, I mean, I agree. I don't think transformers think in the same way that humans think, right? There are clearly some things missing. Like you mentioned, being able to think in these explanatory knowledge terms versus just statistical relationships between input-output. There's the whole thinking fast and slow models of the human brain. There's the kind of recurrent thought patterns, and transformers spend the same amount of compute on every token they're predicting. That's not how we as humans think, right? I might say something's really fast, and then I spend more time thinking about the next, a more difficult topic, and really trying to wrap my head around what I think and what I want to say. And so, yeah, I agree. There's certainly things missing in having in silico intelligence mimic what we're seing in natural, neuronal biological intelligence. So I definitely agree with that. This is so I had picked out this quote from The Beginning of Infinity, which I think is very, very relevant to this topic here. So I would love to read it and then get your reactions to it. And so this is, again, the book is called The Beginning of Infinity by David Deutsch. And the quote is, for context, the book was published in 2011, so over 10 years ago. Even if chatbots did at some point start becoming much better at imitating humans or at fooling humans, that would still not be a path to AI. Becoming better at pretending to think is not the same as coming closer to being able to think. A non-AI program cannot fake AI.
Yep. I feel like that's exactly what we were just saying.
Yeah,
What a great take from 2011. Very prescient take. It's certainly my stance that these systems are phenomenal at faking what it looks like to think. So much so that it's like convinced a lot of people that they are capable of thinking and reasoning. But I agree with David Deutsch. I don't think that gets you any closer to a truly reasoning and thinking system, which is, I think, what we are aliasing to AGI.
Yeah. I mean, I think the world needs to catch up here, right? There used to be the Turing test that has now been passed and exceeded, right? Mm-hmm. We can, probably a couple of years ago could fake a human conversation and fake most people into thinking they were conversing with a human. Yep. And with, GPT 3.5 and certainly 4 kind of totally maxed out on all the standard evaluation metrics and just maxed out. And yet we're still not there in terms of intelligence, and we're still not there in terms of matching human intelligence. So we need to come up with new metrics and new ways to evaluate, like, how close are we to intelligence?
I completely agree.
I feel like we could definitely keep going for a while here. I wanted to ask you about the Mr. Beast Squid Games video that you built hardware for and helped, get up and running. I feel like we could talk about AGI for hours longer, but I think we might just save it for a part 2. And so, George, to kind of wrap up here, anything you want to ask of the audience, and where can people stay up to date with your work?
Totally. Yeah, I would say if anyone in the audience is interested in kind of what comes after the era of deep learning, check out our website, Symbolica.ai, and follow us on X, Symbolica_AI.
Amazing. Well, thank you so much. And we'll add those to the show notes as well. Thank you, George. This has been a blast. And until next time.
Thanks so much, Lina. Appreciate it.
Thanks for listening to The Edge of Infinity, an AI podcast. You can find all show notes, transcripts, and resource links to all of our episodes at blog.infinity.ai. I'm your host, Lina Avancini-Colucci. You can find me on Twitter at Lina_Colucci. That's LINA_COLUCCI. Thanks for listening, and until next time.